Okay, so now we're going to look at example number 6. And when I see ln x, I'm just going to think about what does that look like as a function. And remember that there is a vertical asymptote at x equals 0. So you can see that your lower limit of integration is where there's a vertical asymptote. So that's why this is an improper integral. So we are going to change that to the limit as a approaches 0. So we're changing our number to a letter where the vertical asymptote is, and we're going to approach that number with our letter. So the limit as a approaches 0. Now I have to think about, is it coming in from the right or from the left? So when I think about the integral from 0 to 1, it's going to be this area right here that I just shaded, and you can see that you're going to be coming in from the right integral, integral from a to 1, ln x dx. Now, this integral, sometimes kids get confused and they think, oh, the integral of ln x is 1 over x. No, that's the derivative. So when you are integrating ln x dx, you must use integration by parts, and we must make our u ln x. So I'm just going to, remember that we have du and v and dv, but this initial has to be our u dv here, because we're integrating u dv when we're using integration by parts, and so our dv is just our dx. That's all that's left to be dv. And so I take the derivative of ln x, 1 over x dx. I integrate, right? You're integrating dx, which is just x. And so now that gives us the limit as a approaches 0 from the right. This is going to be u times v, which is our x ln x, minus the integral, and this would still be from a to 1 v du. So this would be x times 1 over x dx. And of course those x's are going to change to 1. So this is just like integral of dx. So limit as a approaches 0 from the right, x ln x minus, and then since this is just integral of 1 dx, this is just x, whole thing from a to 1, which gives us the limit as a approaches 0 from the right. If I put my 1 in, 1 times ln 1 minus 1 minus a times ln a minus a. So think about ln 1. Remember that's 0, so this whole thing goes to 0, but you're still left with a negative 1 there. And then you're putting in very small values. You could never actually put 0 in to this right here. That one, it can never be 0, okay? And that's why it's important to say that we're approaching it from the right. But if I have, and this is going to be a strange thing to think about, but if I have, if I'm putting zeros in, so I'm putting, basically very small numbers here, I'm going to go ahead and say 0 because it doesn't get us in trouble. But here, I have to think of it as very small values that will never actually be 0. You can see that your ln x never actually, you can never put 0 in. You can see that it approaches that value, but never gives it to you. But the thing that's going to be spitting back out are very small values times, again, very small values over here. But still, this entire thing going to 0, okay? And this, of course, would be plus a, and if we put 0 in for a, again, we're saying 0 when it doesn't hurt us to say 0. But in ln, we can't actually put 0 there ever. That's why it has to be approaching it from the right. And really only from the right, because ln x doesn't even have values where you would approach 0 from the left. So what ends up happening here, this is a weird one, but your answer ends up being -1 and therefore converges. So please be careful on these natural log limits because they are a little bit tricky. All right, so now example number 7. This one, if I, sketched a little graph of it, I would have a vertical asymptote at 1, and then we've got 2, 3, I don't know, I'm not gonna really draw a great graph of it, but I'm just imagining that it's 1 over x shifted to the right 1. And if I was going from 0 to 3, you could see that I've got 2 places that we're going to have a problem. Coming in from 0 to 1, where I would be approaching 1 from the left, I would have to, take that and make that a limit, and that would be my b, would be approaching 1 from the left because I would be going from 0 to 1. So that would be my upper limit of integration, 1 over x minus 1 dx, plus, and I kind of am running into this, sorry, I'm going to have to write it down here. This time, it's going to be my lower limit of integration, and I'm going to be approaching 1 from the right. So the limit is a approaches 1 from the right, integral a to 3, 1 over x minus 1 dx. Okay, so now we're going to do a nice easy integral here because it's 1 over x minus 1, so that integral limit is b approaches 1 from the left is ln absolute value of x minus 1 from, oops, I accidentally forgot to put, sorry, up here, that should have been a b. Did you catch me? I hope you caught me. So from 0 to b, plus, and then this would be limit as a approaches 1 from the right, ln absolute value of x minus 1 from a to 3. Okay, so now limit as b approaches 1 from the left, ln absolute value of b minus 1 minus ln absolute value of -1. So we do need those absolute value signs. Limit as a approaches 1 from the right. We've got ln absolute value 3 minus 1 would be 2 minus ln absolute value of a minus 1. Okay, so now the absolute value, this guy right here, absolute value of 1 is 0. Okay, so that one does go to 0. Let's think about ln of b minus 1 as b approaches 1 from the left. So 0.99999 minus 1. So, and then you take the absolute value of it, it's going to be approaching 0. So this one is going to be approaching -infinity. So if this one approaches -infinity, then you know that you have one thing that's divergent. You really don't even have to worry about the second one because you've got the one that is diverging. So therefore, for this limit, it is undefined, or this integral, you could put d and e, but you definitely need to say that it diverges. Okay, and I think that's it for our 7 is it 6? Nope, 7.5.